Hello, my dear friends and my dear all physics students. This time I have come up with the video on talk, जिनमें हमने basically moment, couple, talk से related सारे basic fundamentals clear करे हैं and करने की कोशिश करी है and of course which would be considered as basic fundamental for 10th as well as 11th CBSE and ICSE. अच्छा, लेकिन ये बात एक और बहुत इम्पॉर्टेंट है कि ये बेसिक फंडामेंटल रोटेशनल के हिसाब से बहुत ही ज़्यादा इम्पॉर्टेंट टॉपिक है जो जेई और नीट के लिए भी कवर अप करता है. आइए चलते हैं, लेट्स गो ऑन टू आवर वीडियो. लेकिन उसके पहले आप हमारे चैनल को सब्सक्राइब कीजिए, लाइक कीजिए एंड तब तक विद इन सेकेंड्स आई एम कमिंग अप. सी यू. What is force and how do we relate force with that of rotational motion?
Well, we know that force is the push and pull which happens from the interaction of one object with another.
That means force might be causing two types of motion. One linear motion and the other rotational motion.
Which happens due to turning of the object is rotational motion, if I think.
Yes. So that means when force cause any linear motion or translation motion, that means we are simply pushing the body in linear direction. And when any force is causing rotational motion, then what did you say?
That is due to turning effect.
That means we are trying to turn.
It happens when a body rotates.
These two phrases can be thought of into another, I would say. That means turning force might be causing rotational motion, or rotational motion is due to turning effect. So hence we could say
this also happens when we play with the ball. We can observe linear motion. And about rotational motion, for example, how can I relate rotational motion to daily life?
Rotational motion, just you see above your head the rotating fan.
Oh yeah, I didn't think it.
Just look upon the door. When you pull the door or push, door might be closing or opening like this.
Yes.
This door has started rotating about the axis of rotation. This is how rotation we come across in everyday life. Just see this translational motion. Body, this spherical ball, upon this spherical ball, pushing force is applied, and because of this, ball is moving in forward direction. But at the same time, see how rotation occur in everyday life. See this wheel, and this is force, and after application of force, wheel has started rotating about this axis of rotation. See at the center what is mentioned? That point is pivot, and this is basically axis of rotation. You could turning force if the body is pivoted at a point and the force is applied on the body at a suitable point, it rotates the body about the axis passing through the pivoted point. This is the turning effect of the force, and the motion of the body is called. So this is proper definition. And here we have got moment, which is turning effect of a force, or torque. Very new term, torque, which is rotational effect of force,
Which is the product of magnitude and the perpendicular distance of the line of action of the force from the rotation of from the axis of force.
This is the body, and suppose I'm applying, this is the force. Axis of rotation is located here. Here is the pivot. That means body, after application of this force, body will be having tendency to rotate like this. Force into force arm would be like this: force arm, and force arm should be perpendicular to force. This moment would be termed as, and what perpendicular distance? I'll be specifying. OP is perpendicular distance. The conclusion is torque, that is moment of a force, is equal to magnitude of force multiplied by perpendicular distance, which already I have explained in some other language. Can you explain this perpendicular distance?
Well, this perpendicular distance,
in fact, let me repeat once more. It is the straight line distance from the line of action of force to axis of rotation, that means pivot. That means, again, some other way, perpendicular distance from line of action of force to pivot. This is most simplest language would be line of action to pivot is perpendicular distance, such that both the lines should be perpendicular. Point to be noted.
yes.
Otherwise we could have less than 90 degree also, that OP, or more than 90 degree, but that line won't be considered as perpendicular distance unless and until we take as pivot. SI unit for this torque or moment would be force into force, that means Newton into meter, that is Newton meter. What are the factors affecting this turning?
Yeah, like as I mentioned, torque is the product of magnitude and the perpendicular distance of the action of force from the action, and these are the two factors which affect.
So that means first factor is magnitude of force, and the second factor is that way perpendicular distance. These are the two deciding factors, and one simple application in everyday life. While pushing the door, you try to apply the force in outer part of the door.
This kind of works with this pivot, with the pivoted point. Like there's a pivoted point.
That means your point of application of force is preferably farthest from the pivot.
Yeah, and we aren't able to definitely we aren't able to see it, but it also forms a perpendicular distance, and that is how it affects the turning of a door.
You must have marked the turning effect on the body about an axis due to the moment of force applied on the body. So hence 1 Newton meter is 10 raised to 7 dyne centimeter, because normally we remember 1 Newton is 10 raised to 5 dyne, but 1 Newton meter is 10 raised to 7.
But here there's also centimeter, right? So that's why.
The moment of force, so this is 5
moment
Newton.
Of force is already good. 5 meter would be our magnitude then, because if we derive it from there, then we'll definitely get this.
Calculate the distance point of application.
Moment of force by magnitude is equal to perpendicular distance.
Clockwise and anti-clockwise moment. And anti-clockwise is considered positive. That means whenever after application of force there is some anti-clockwise movement, that is considered positive moment, and when after application of force there is some clockwise movement, then suddenly you may think, why do we require this positive and negative? We never had this positive and negative, same physical quantity, positive and negative values. So because now for the purpose of exact quantitative analysis, we need to apply some certain sign convention. What the net result is. In the same body, there is some clockwise motion also. In the same body, there is some anti-clockwise motion also. We need to sometime analyze or we may have in our mind, then let's try to explore what kind of net motion was there after application of plenty of n number of, mark this point, very important, while of clockwise moment is inwards. How will you justify this inward is negative and outward is positive? You need to remember outward means positive and
positive means anti-clockwise.
Yeah.
Inward means negative and negative means clockwise.
Everyday phenomenon. Let me bring even you see, this is my screen cleaner liquid. In the process of opening, you just have started rotating this cap anti-clockwise. And in the process, what you saw, it is opening up. But when you want to close this cap, so now you have started rotating clockwise.
Yes, and now it's negative. And the rotation is inwards. That's the rotation.
Yes, that's why we never say close up, open up, we say. Close down and open up.
Okay, so the direction of rotation depends on the direction of force and also the point of application of the force. Thus, the rotation of a body can be changed in two ways. By changing the point of application of force and by changing the direction of force.
Here we have common examples of moment of force. This is very important for us to discuss. Opening of a door. See, handle is located at farthest end from the hinge. That means this is axis of rotation and this is handle. What would have happened if we would have located our handle here, suppose, as compared to...
Yeah, like we have also noticed that if we apply force on the outward end, we apply less force, while when we apply it on the middle or very much near to the screw which or the frame which fixes it to the wall, more force is required to close the door.
More? Why?
Yeah, that has also been given, because smaller the force at a larger perpendicular distance is the maximum moment of force.
That means product of FR should be maximum for effective moment.
It is force is inversely proportional to perpendicular distance of the line of action of the force from the axis of rotation.
For effective moment or effective door pulling or push, we need to have maximum value of F into R, but at constant value of F, we need to have maximum value of R.
So basically we can derive this that magnitude is inversely proportional to perpendicular distance.
For existence of couple, there should be a pair of equal and unlike forces, whereas in case of moment was needed only one single force. Both moment and couple is rotational force only, but previously we read moment, that was also a rotational force. Now couple, that is also because of rotation, that is rotational force only. Second type of rotation or alternative name for both the rotational forces, torque. So that means I would like to summarize that torque is, there are two types of torque. First is moment and the other is torque. When a single force is in the picture, then
so it's moment of force.
Moment and a pair of force, that means
then it's a couple.
अब लेकिन most important phrase to understand is pair of equal and unlike forces. Now I'll try to draw the diagram wherever we need it. How do we generate couple in everyday life? In the process of opening the cap of a bottle or tap, ऐसे करके देखो आप, just see my fingers. You are applying at any moment of time a pair of equal and unlike forces. Either force into perpendicular distance between equal and unlike forces. ये जो diameter है उस circle का. Magnitude of this torque would be, I'll mention here only, right? So that you could have same thing in the same diagram. So couple or torque is equal to either force into perpendicular distance between parallel forces. This is top view of a bottle cap, and this white line which is in the form of diameter is perpendicular distance between parallel forces. और in the process of opening any bottle आप तो कई सारे position दिखाते हो ना, मतलब you are into different position at different instants, like this, like this,
Yeah.
like this, like this, like this, like this. In the process of rotating, my fingers positions are also changing accordingly. A couple is always needed to produce a rotation, which already we have discussed. Even in the process of driving your car, your steering wheel also you are requiring.
It's just that a cap is really like small, while a car's steering wheel is very large. So it's basically the same motion is happening.
The two forces cannot produce the translational motion as their resultant sum in any direction is zero. Another reasoning question: why they can't produce linear motion? But each force has the turning effect on the bar in the same direction. Thus the two forces together form a couple which rotates the bar about the point. मतलब in a nutshell इस discussion का main point ये है, conclusion, that these pair of forces can't be applied for the purpose of generating linear motion. मतलब इस तरह के pair of forces जिनका lines of action different है, of course उन दोनों pair of forces का magnitude same है लेकिन opposite direction भी है, and moreover उनके lines of action different है, लेकिन वो linear motion cause नहीं कर सकते, उनके वजह से rotation ही होगा. And when a number of forces acting on a body produce no change in its state of rest or of linear or rotation, the body is said to be in equilibrium. And obviously in all the situation of torque or moment or couple, always we'll have total clockwise torque is equal to total anti-clockwise torque. There in case of moment also, in case of couple also, whenever equilibrium is to be needed. In the given situation, these two are a pair of equal and unlike forces, and they are separated by this distance d. That both the pair of forces has got same magnitude, f. Here also f, here also f. But at point A, f is causing anti-clockwise, and this is also anti-clockwise.
Yes. I was just going to tell it now, like both of them are the anti-clockwise.
Yeah, so in case of couple, unless and until more number of pairs would exist, we can't have clockwise and anti-clockwise both. Now indirectly we are going to prove in the given situation force into force arm, moment of force for both the situation. So if we try to find the moment, here both are anti-clockwise moment only, is equal to force into force arm, F into d by 2. Then moment at point B also, that is also equal to F into d by 2, and this is also positive. So then total moment would be, total moment positive is equal to,
this is how we can derive how we calculate torque or the.
And in the given situation, for either force यहाँ पे क्या है, F है into perpendicular distance between parallel forces. This is perpendicular distance between parallel forces. यही तो D है का.
हाँ.
यानी दोनों तरीके से same torque is Fd and torque or couple is equal to Fd. That's why I said moment of couple is either force into perpendicular distance between the two forces or couple arm. The body is said to be in equilibrium. Obviously, despite the presence of plenty of number of forces, if body is still in rest or in equilibrium, that means
it is said to be in equilibrium even if there's a number of forces which are acting on a body, but still it doesn't produce any change in its state of rest or in its state of motion, whether it's linear or rotational, then it is said to be in the state of equilibrium.
In the given situation, net force is also zero, and along with net torque is also zero. Body is related to only forces, number of forces.
Okay.
And dynamic moments also. Total clockwise torque should be equal to total anti-clockwise torque. In case of static equilibrium, only forces are to be considered, but dynamic equilibrium, clockwise torque should be equated to anti-clockwise torque or moments. Maybe moments. Clockwise moment should be equated with anti-clockwise moment. Lastly, condition for equilibrium. These are the resultant of all the forces acting on the body should be equal to zero. That means net force is zero. And then thereafter, the algebraic sum of moments of all the forces acting on the body about the point of rotation should be zero. Algebraic sum of moments means total clockwise moment should be equal to total anti-clockwise moment. यही है principle of moment.